So there was a fun little intro to some music. So if you haven't already guessed, my lesson is about the normal distribution. So we're going to have an introduction part, a body part, and a wrap up. So I'm going to take you through a quick little run through of what the lesson overtures are and then how you could use it inside of your classroom. The thing that I really like about this lesson is that you can then use it and extend it to an understanding of areas under curves, which is the integral in calculus. You can also use it to help kids understand where z-scores are coming from a z-score table if that is your end result. Our results just the empirical, our end goal is just them having a good understanding of the empirical rule, which is that 68%, which is one standard deviation, two standard deviations is 95, and then three standard deviations is at 99.7%. So here's just what I would do for a warm-up. There's some videos out there, and a lot of the normal distribution videos out there aren't the best. I do have one linked in my lesson plan, and it's talking about how they use the normal distribution in a long-term biological study in the Northeast, and it's really interesting. So it could be an interesting tie-in for your students. It's around 10 minutes. So another way you could go about introducing this lesson is just talk about the different types of distributions that they've studied so far in class. So you have those, you have your skewed, you have your random, and you have your bell shape, and then you come to a normal distribution. So normal distribution, make sure it has no skew, symmetrical. We have mean, median, mode. Those are in the center. So then this is kind of where I think pair share can happen inside of the classroom. So you have the left side question, right side question. So determine if they're normal and give a reason why. So you make your kids think, is it normal? Yes or no? If it is, why? And then they share with their pair, and then you call out on a few different people to get their thought processes. So we have a few of those built in this slide. So we got 1, 2, 3, 4, 5, 6, 7, 8. And then we talk about standard deviation. So standard deviation is just the measure of spread about the mean. So a small spread is going to be really tight, a big spread is going to be really fat. And sometimes I think this is hard for kids to see. I still have 100% of data or information underneath those curves, just my standard deviation is going to make those either kind of a skinny or a big one. And this is stuff you can kind of get into kids talking about it, which one has a larger mean, which one has a larger standard deviation of those information. And then, you get to the normal curve. So now we have the intro out of the way. So now we're talking about the meat of the activity. This should take depending on your kids, 20 to 25 minutes, depending how good their spatial reasoning is. So we need to estimate the number of rectangles that fit underneath this normal density curve. So the area under a density curve is 1. Here's a question to extend to get kids talking about why is the value 1, what does that mean in terms of the problem, and all sorts of that. So here's the next thing. So I have it broken up into a grid. So you just get them counting. These whole ones are going to be the super easy ones for them to do. Okay, so the next part is this is where I see kids start to kind of have trouble. It's like, oh, I have this right here, but I need to combine it with something else to make it a whole one. So maybe I can combine it with that one right there and that one. So those three then would be a 1. And so what I find is if you allow kids to use highlighters in different colors or colored pencils, let them go through and get the full grid ones, and then whatever they're combining, let them use a color. It helps them kind of keep track, and sometimes that spatial awareness of how I can combine this is what I watch for, combine things that aren't technically full and say it's a whole works. So then you get that. So then we know how many are underneath. So another extension that you could do is have each group, because I'd break them down into groups, and probably no more than 3. 2's a great group to do on this activity, and then keep track of how many they're getting for the class, because it should be pretty uniform, pretty standard, and you can talk about that, so, and why it works that way. So then that's 1. So this is the thing, the next part we want to do is everything below 0. So you can come in, I'd have them highlight from here down and then figure out how many are below 0, because it's half of it, should be pretty straightforward. So then they do that one. So they have an idea, 50% below, 50% above is what we're trying to get out of that question. So the next one is from a -1. So everything above, everything below. So shade everything in there, and then you want them to figure out how many squares they have, because you write it there, and then what is your estimate for this proportion. So what do they have there over the total? Let's say the total is 36. I have no idea. Let's say they got 20. And then you want them to write it as a percent if they're doing good. I know it should be that as a decimal and a percent, right? So there'll be some variability there. So then you do it with the twos, -2 to a +2, and then you do it from out here at a 3. And the 3 is a little bit of an interesting one because you only have a little bit, so it's like using that spatial awareness estimation skills out there at the end, and then you have that. So then this is question 6. So that's kind of the bulk of the activity. So that takes them some time. And so you have that whole thing. So use a standard normal table to complete this column to help them do this. So sometimes I'll go around and explain that to groups and have them share out who's ever going faster. And sometimes I'll just be like, oh, everyone's there together. Okay, hold. And then I'll talk to them how to use the Z table to get this information. And then this is where they write what they got through problems 2 through 5 right here. So then the whole thing is the comparison between them doing their own personal square grid comparison versus that, and you have that huge good pull back together class discussion why they're the same. So tying that activity back into this big learning idea. So that's the main body, and then you have the wrap up. The wrap up's just basically talking about the empirical rule, tying what they did with their table to what's happening with the empirical rule, 1, 2, 3 standard deviations out. And the best thing you can do is like make them think through, where does it come from? How can you remember it? What are the important pieces to remember for this lesson?